Hello, and welcome to this lesson of our C Programming Foundations tutorial series. I'm Reza, and I'm happy to have you join me on this journey to mastering the C programming language. In the previous chapter, we highlighted that data and algorithms are the two fundamental components of every software system. To illustrate the concept of these two elements, we explored a simple case study. In the previous videos, we delved into data structures and got to grips with the various types out there. This time around, we're going to switch gears and explore a whole new toolbox, the tools we use to implement algorithms. It's like moving from learning about the ingredients in cooking to mastering the kitchen tools that bring it all together. Just as a chef uses different utensils to create a dish, in programming, we use different tools to craft and execute algorithms. Let's dive in and see what these tools are and how they help us turn our algorithmic ideas into working solutions. In this chapter, we're going to look into the building blocks for constructing algorithms in the C programming language. As we dive in, it's important to understand some fundamental concepts that form the backbone of any C program. These concepts not only define how we manipulate data, but also control the flow of our programs. Let's start by looking at the key elements we'll be exploring in this chapter. 1. Operators. Operators are the building blocks of expressions in C. They enable us to perform various operations on data, making it essential to grasp their functionality. From basic arithmetic to bitwise operations, operators are the tools that allow us to work with data effectively. 2. If-else statement. The if-else statement is our gateway to decision-making in C. It empowers us to create programs that can make choices based on conditions. Whether it's validating user input or responding differently to specific situations, if-else statements are our go-to construct for branching execution. 3. While loop. Loops are the secret sauce for repetition in programming, and the while loop is a powerful tool for this purpose. It allows us to execute a block of code repeatedly as long as a certain condition is true. Understanding how to construct and use while loops is key to creating dynamic and efficient programs. 4. For loop. If the while loop is the workhorse of repetition, the for loop is its organized cousin. It provides a compact and structured way to iterate over a sequence of values. We'll explore how the for loop streamlines repetitive tasks and how it's particularly handy in scenarios where we know the number of iterations in advance. Alas. Now let's dig into each of these topics, starting with operators. These concepts are the foundation of your journey into C programming, and mastering them will open up a world of possibilities in software development. Let's get started. Operators are the tools that empower us to manipulate data and perform various operations. They allow us to work with variables and constants, enabling us to create dynamic and flexible programs. Categories of operators. 1. Arithmetic operators perform basic mathematical operations. Examples: addition, subtraction, multiplication, division, and modulus. 2. Relational operators compare values and return a Boolean result. Examples: equal, not equal, less than, greater than, less than or equal to, and greater than or equal to. 3. Logical operators perform logical operations on Boolean values. Examples: logical and, logical or, and logical not. 4. Assignment operators assign values to variables. Examples: assignment, add and assign, and so forth. 5. Increment-decrement operators increase or decrease the value of a variable by 1. Examples: increment and decrement. 6. Bitwise operators operate on individual bits of integers. Examples: bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift, right shift. This table provides a simple example for each arithmetic operator. This C program is designed to convert the temperature from Celsius to Fahrenheit. This simple utility demonstrates basic arithmetic calculations in C. 1. It starts by declaring two variables, Celsius and Fahrenheit, to store the temperature values. 2. The program then prompts the user to input a temperature in Celsius, which it reads and stores in the Celsius variable using the scanf function. 3. Next, it performs the conversion to Fahrenheit using the formula and stores the result in the Fahrenheit variable. 4. Finally, the program displays the converted temperature in Fahrenheit formatted to 2 decimal places using the printf function. This table provides a simple example for each relational operator. And this table provides a simple example for each logical operator. This C program demonstrates the use of logical operators by evaluating conditions with 3 integer variables a, b, and c. Initially, it sets a to 5, b to 10, and c to 15. The program then uses a series of if statements to check various conditions. The first if statement uses the logical AND operator to check if both a and b are greater than 0, which is true, so it prints both a and b are greater than 0. The second if statement uses the logical OR operator to check if either a or b is less than 0. Since both a and b are positive, this statement doesn't print anything. Finally, the third if statement uses the logical NOT operator to check if c is not less than 0. This condition is also true, leading to the printing of c is not less than 0. This program effectively showcases how logical operators can be used to evaluate conditions and control the flow of execution in a program. Here is the truth table for the logical OR, AND, and XOR operations. The truth table shows all possible combinations of input values a and b and the corresponding results of each operation. This table provides a simple example for each bitwise operator. This C code demonstrates bitwise operations on 2 hexadecimal numbers, num1 and num2. When you run this program, you'll see the output that shows the results of the bitwise AND, OR, XOR, and NOT operations on the given numbers. And this table provides a simple example for each unary operator. This C code demonstrates the use of basic arithmetic and assignment operators on integer variables. The main function, which is the entry point of the program, starts by declaring and initializing 2 integer variables, num1 and num2, with values 5 and 10, respectively. These initial values are then printed to the console. Following this, num1 is incremented by 1 using the plus operator, and num2 is decremented by 1 using the minus operator, with their new values printed again. The code further manipulates these variables by using compound assignment operators. Num1 is increased by 3 and num2 is decreased by 5. The final values of the variables are then printed.